Welcome to the AI checkpoints. We're all incredibly excited about AI agents fundamentally transforming our daily lives. They're automating tasks, connecting to more and more systems, and honestly, making us wonder what a world of truly intelligent digital assistants will actually look like. But as these agents get smarter, more integrated, and frankly, more autonomous, there's this huge question looming large. How do we keep them secure?
Yeah, and what's fascinating here is that it feels like we're facing what Jared Hansen, the co-founder of Keycard and creator of Passport.js, he called it an impossible choice in his presentation on securing agents with the OAuth.
An impossible choice, huh? What's the dilemma exactly?
Well, it's pretty stark. Either we grant these agents really broad, powerful access to, unlock their business value and truly transform workflows. But doing that, we might be accepting massive, unforeseen security risks, like really big ones.
Or the alternative.
Or we tightly limit their capabilities, restrict their access, but then we sacrifice that very business value we're so keen to achieve in the first place. It's a tough spot.
That really is the core tension, isn't it? And it's not just theoretical anymore. We're seeing real incidents. You mentioned the DeepSeek chat log leak that Jonathan Mortensen from Confident Security highlighted.
Exactly. Or even the need for much stricter data retention policies, even at places like OpenAI, just because of the sheer volume of sensitive data these models handle. And as agents move beyond just, chatting, beyond simple queries, to actually taking actions.
Right, like calling APIs, kicking off complex workflows, actually making changes in critical systems.
Yeah. And then the need for robust security and privacy, it just goes from important to absolutely critical, non-negotiable, really.
Okay.
So to really understand this challenge and figure out how we might overcome it, we've gathered insights from leading experts across the field. We're pulling from the work at Keycard, OpenAI, Authly, and we're even diving into Apple's pretty innovative approach to private cloud compute.
Sounds like a great lineup.
Our mission today is basically to unpack what's really happening behind the scenes, maybe learn from what's gone wrong, and pull out the most important nuggets of knowledge, the things that can help us build a safer, more trustworthy AI future.
So what does this all mean for you, the listener? Whether you're, developing these next-gen agents or deploying them in your business, or maybe you're just curious about the guardrails being put in place. This deep dive, it's designed to give you a shortcut, help you get well-informed without getting buried in jargon or, just the sheer amount of information out there. We'll explore the core problems, the foundational solutions already being used, practical safeguards you can implement today, and even look at the bleeding edge of privacy and advanced authorization. So yeah, let's unpack this.
Okay, let's start by really trying to grasp the scale and the nature of this challenge. Our experts seem to agree pretty strongly on one crucial point. Pretty much every agent is rapidly becoming a code-executing agent. That's a key insight. Food Matan from OpenAI really emphasized this in his talk on agent robustness. He was saying the latest AI models are just so incredibly good now at writing and executing code. They'll just decide to use that tool if it's the most efficient way to get something done.
Even if you didn't explicitly tell it to write code.
Right. And he hilariously called this remote code exploitation.
Yeah.
In a security context. Even when the agent isn't being malicious, it's just trying to be effective, but it's executing code.
Wow. Okay.
And if we connect this to the bigger picture, this fundamental shift, it just completely changes the risk landscape. Bobby Tierney and Cam Sween from OAuth really highlighted this. Common practices today, like developers pasting shared long-lived API keys right into config files.
Yeah, we've all seen that or done it.
Exactly. It's incredibly fragile in this new world. And Jared Hansen from Keycard warned about this too. He said continuing that pattern for hundreds, maybe thousands of AI agents, well, it creates a pretty big security problem.
You can see why. Imagine trying to manage that. Revoke keys, audit access.
It's chaos. The attack surface becomes immense.
Yeah.
A single compromised key could lead to, widespread system breaches.
Exactly. You just completely lose track of what's happening and, frankly, who's responsible for what action. The OAuth team had a good term for it, excessive agency, or the classic confused deputy problem.
You're right, the confused deputy, where an agent has legitimate access, but it maybe doesn't know who it's truly acting for.
Or it just lacks the context to understand what actions it shouldn't take. It's like giving your super eager, but maybe slightly clueless assistant full, unrestricted access to your entire bank account. No limits, no oversight.
Yeah, no way to say, hey, maybe don't buy that yacht for me today. It's an alarming level of trust with, zero guardrails.
Okay, so that paints a scary picture. What are the specific ways these agents can actually go wrong in practice? Food must have touched on that.
He did. He outlined several common issues.
Sure.
First, there's prompt injection. That's where malicious content gets subtly woven into a user's prompt.
Tricking the agent.
Yeah, tricking it into executing commands or revealing sensitive info it shouldn't. Then there's data exfiltration. Big concern there. Confidential data just leaks out because maybe the agent is processing untrusted external content or it's just not properly siloed.
And it's not always malicious actors, right? Agents can just mess up.
Exactly. It's not always malice. Agents can make genuine mistakes, like unintentionally installing a vulnerable or malicious package from, say, a public repository, or even writing flawed code themselves that creates new vulnerabilities in your system.
Oof.
And without proper guardrails, these kinds of issues can quickly lead to privilege escalation. The agent gets more access than it should, or even sandbox escapes, where it breaks out of its confinement.
Okay. So the risks are clear. But you mentioned Jared Hansen also said we've kind of solved similar problems before.
That's the hopeful part. He pointed out, quite rightly, that we've actually built robust protocols for managing exactly this kind of delegated access before. He strongly believes we know how to transition away from static secrets to dynamic access using OAuth.
OAuth. Right. For those listening who might not be deep in the weeds, what is OAuth basically, and why is it suddenly so critical for these AI agents?
Okay, so OAuth, at its core, it's a protocol. It lets applications, we call them clients, securely request and get limited access to APIs or resource servers, but they do it on behalf of a user.
Limited access being key.
Crucial. And these requests are always mediated by a trusted third party called an authorization server. Jared Hansen used a perfect example. If you've ever connected, say, Calendly to your Google Calendar,
Yeah, done that.
you've used OAuth, Calendly asks Google for permission. Google's authorization server checks you're logged in, that asks you explicitly, is this okay?
Right.
If you say yes, Google sends Calendly an access token. Calendly uses that token, not your password, to talk to your calendar.
And that token isn't permanent?
Exactly. It can be short-lived, it can be scoped just for specific actions like only reading calendar events, not deleting them, and it can be easily revoked. It moves us away from those dangerous static API keys that live forever.
So the key takeaway then is that the APIs themselves, the resource servers, they don't have to worry about passwords or logins or consent flows anymore.
Right. They offload all that difficult security-critical stuff to the authorization server. All they care about is, does this request have a valid token? It makes their job way easier and much more secure.
Got it. That makes sense.
And one common point of confusion Jared Hansen clarified was using OAuth for things like sign in with Google.
Right, because that feels like login, like authentication.
It does, but it's actually a special case of OAuth. The API in that flow is really just returning verifiable claims about the user, their ID, name, email, stuff like that. This pattern got so common it was actually standardized as OpenID Connect, which is basically an identity layer built right on top of OAuth.
Okay, so OpenID Connect for identity, OAuth for access delegation.
Precisely. And the Auth team really reinforced this. Identity is the bedrock. It's what connects an agent's actions back to a real user. That lets you trace activity, audit behavior, make decisions about what should happen next. Without strong identity, even the best token scoping won't give you real control. You need to know who the agent is acting for.
Okay. So identity plus dynamic authorization via OAuth gives us a foundation. But you mentioned agents running actual code, making potential mistakes. What are the really practical safeguards we can layer on top of that?
Right.
Fuad Matin from OpenAI must have had some thoughts there from their work with Codex and ChatGPT.
Absolutely. And this raises a big question for developers and security teams. How do you actually build and deploy these things without opening huge new holes? Fuad Matin emphasized the first, maybe the most fundamental safeguard is to sandbox the agent.
Sandbox it, like put it in a box.
Metaphorically, yeah. Give it its own isolated container or, as he put it, its own computer. Create a secure perimeter around its execution environment. He even mentioned that with Codex CLI, OpenAI actually open-sourced their sandboxing techniques for macOS and Linux. They use powerful OS tools like Seatbelt and Second Plan Lock.
What do those do?
They create a highly restricted environment. They prevent the agent from messing with your local machine or other critical systems, even if it tries to do something wrong or gets compromised itself. Think of it like putting your eager but potentially destructive assistant in a soundproof, padded room with only the exact tools it absolutely needs, nothing more.
Okay, a padded room for the AI. I like it. So it can't harm the local machine. What about its access to the outside world, the internet? That seems like another huge danger zone.
You're spot on. That was the next critical safeguard Fouad 10 highlighted. Disabling or severely limiting internet access.
Yeah.
It's a primary vector for prompt injection, like we talked about, and also for data exfiltration.
How so?
Well, imagine an agent reading, say, a GitHub issue or some public document. A malicious comment, or maybe some hidden payload in that document, could inject untrusted commands right into the agent's process.
Leading to data leaks or unauthorized actions?
Exactly. So OpenAI now offers configurable allow lists. It strikes a balance. Maximum security by default, but flexibility for specific tightly controlled cases that genuinely need external network access. It ensures agents only see and touch what they absolutely need to.
Makes sense. Containment both locally and network-wise. And finally, you mentioned something that sounds almost low-tech but powerful, requiring human review.
Yeah, it sounds simple, maybe even counterintuitive in the age of AI, but it's proving incredibly effective, especially for high-stakes actions. Fouad 10 really underscored this. He said, while AI monitors are useful for flagging weird stuff, they're absolutely not a substitute for real human review of critical operations.
Like code changes.
Especially things like code changes in a GitHub pull request. Humans need to stay firmly in control of the ultimate decisions there. And building on this, Bobby Kearney and Cam Sween from OAuth showed off a really fascinating flow called CIBA Client-Initiated Back-Channel Authentication.
CIBA, how does that work?
It's pretty neat. It lets an agent running silently in the background, maybe on a server, maybe an embedded device, send an approval request directly to the authorization server. The server then reaches out to the actual user on a trusted device, like their phone, probably via push notification.
Ah, so the user gets a prompt on their phone.
Exactly. Do you approve this action? Like authorizing a big financial transaction or buying stock that the agent initiated. The user explicitly taps approve or deny. The genius is it gets explicit user consent for high-risk actions without needing a browser UI, which the agent might not even have access to. It injects human judgment seamlessly at critical points.
That is clever. So robust authentication, authorization, sandboxing, limited internet, and human in the loop via things like CIBA. That sounds like a pretty solid set of defenses.
It's a huge step up, definitely.
But what if you want to push things even further on the privacy front? Like really ensure data stays private, maybe even from the service provider. That's where Jonathan Mortensen's unofficial guide to Apple's private cloud compute comes in, right? You said that was fascinating.
It really is, because Apple's Private Cloud Compute, or PCC, it tackles this core privacy dilemma head-on. How do you use powerful remote compute for AI tasks, think voice dictation, image processing, while absolutely guaranteeing user privacy and keeping costs manageable?
That sounds like the holy grail.
Yeah.
What are Apple's requirements for it?
Jonathan Mortensen outlined 5 really stringent ones. First, stateless computation. No user data ever persists on the server after processing. Second, enforceable guarantees through code, not just policy. Privacy isn't just a promise, it's baked into the system's design. Third, non-targetability, making it incredibly hard to isolate or target any individual user's data. Fourth, no privileged runtime access. Even Apple engineers can't peek at live user data. And maybe the most crucial one, verifiable transparency. These aren't just wish list items, they require significant engineering effort.
Verifiable transparency. That sounds almost magical for a cloud service. How on earth do they achieve that? How can you prove what's running on a remote server?
It's pretty innovative. Uses a clever mix of cryptography. Jonathan Mortensen described 2 key parts. First is remote attestation. Your device, say your iPhone, basically asks the PCC server, hey, prove to me what exact code you're running right now.
And the server has to answer truthfully.
It replies with cryptographically signed claims about its genuine Apple hardware and the specific software build it's running. If your iPhone verifies those signatures and trusts the claims, meaning it confirms the server is running the expected secure code, then it encrypts your sensitive data with a public key. And here's the trick. Only that specific attested server running that exact code possesses the corresponding private key to decrypt it.
Wow. So if the server code changes, it can't decrypt old data.
Or new data encrypted for the old code.
Right.
The second part is a transparency log. This is a public append-only database. Think of it like a public ledger. It contains records of all legitimate software releases signed by Apple. This lets anyone, security researchers, auditors, you independently verify what software builds are supposed to be running if a server attests to running code that isn't on that public log.
Red flag. Potential compromise.
Exactly. It makes the black box of the server not just secure, but demonstrably translucent. You can verify its state.
Okay, that is cutting edge stuff. Connecting this back to AI agents, Jared Hansen also looked ahead, didn't he? He talked about what else we'll need beyond current OAuth.
He did. He sees these agent interactions getting way more complex, involving multiple parties and needing even more granular security. He talked about things like agent-to-agent communication. How do agents securely talk to each other, acting autonomously on their own behalf? That probably needs things like the client credentials flow in OAuth, where the agent has its own identity.
An identity for the agent itself, not just the user it's acting for.
Precisely. Which leads to agent identity. How do we securely establish and manage these identities? Maybe using URLs embedded in PKI for cryptographic proof, rather than just manual registration. And another critical area he hit on was agent attestation, similar to Apple's PCC, but for the agent itself. How do we know what LLM our data is going into? How is it trained? Where is it running? Especially crucial for agents running on edge devices where trust is harder.
So it's not just who accesses what, but what is the agent? How trustworthy is it? Where is it running? How is access granted? When is it needed?
Exactly. It's very granular. Jared Hansen introduced transactional authorization, moving beyond broad scopes like read calendar or send email, to authorizing specific actions on a per-transaction basis. Like, an agent needing to make a purchase gets authorization not just for payment, but for a specific amount, for a specific item. He mentioned proposals like rich authorization requests or RAR could help here.
Makes sense for financial stuff.
Yeah, or any high-value transaction.
Yeah.
Then there's chain of custody. How do you protect sensitive data as it moves securely between, say, an MCP server like Apple's PCC and maybe other internal systems or third-party APIs? You need ways to securely pass context and authorization along, maybe using techniques like OAuth token exchange or identity chaining, ensuring every step is trusted.
And lastly,
he touched on asynchronous interaction. How will agents gracefully reach out to users for more access or approval when needed, but maybe not through a browser? Using channels like SMS or push notifications, which ties back nicely to Auth-Gro's SIBA flow we discussed. It's about meeting the user where they are, securely.
wow, okay, we have definitely covered a lot of ground today. From those fundamental risks and the impossible choice agents present, through the foundational standards like OAuth and OpenID Connect, practical safeguards like sandboxing and human review, and all the way to cutting-edge privacy tech and future authorization needs. It's clear this isn't a simple problem.
Not at all. And it's interesting, if we connect this to the bigger picture, Jared Hansen actually described the evolution of the multi-party compute, or MCP, specification itself. He said it kind of mirrors the whole industry's learning curve here. It started with, like, no real authorization model, then a messy first attempt that kind of collapsed different roles together incorrectly. And now it's evolving into a much cleaner draft that clearly separates the authorization server role. That progression shows that these open standards are adapting fast to meet these really complex, dynamic needs of AI agents. It's a collaborative effort.
That's good to hear. So bringing it all together for you, the listener, whether you're building these things, using them, or just trying to understand them, what are the key takeaways?
I think a few things stand out. First, identity is foundational. You have to know who the agent is acting for and link actions back to real, verifiable users. Static keys just don't.
Right.
They're a non-starter for agents.
Right.
Sandbox everything. Containment. Limiting the agent's environment and its access to the outside world. That's your first, most vital defense against mistakes, leaks, and exploits.
The padded room. Got it. Third.
Human oversight remains vital. Don't completely remove the human approval step for sensitive stuff. Even if it's just a quick push notification via SIBA, that human check is crucial.
And finally,
embrace open standards. Things like OAuth, OpenID Connect, SIBA, and these emerging ideas around attestation and transparency logs. They aren't just buzzwords. They are the essential interoperable building blocks we need to construct secure, private, and verifiable AI systems that we can actually start to trust.
okay, solid takeaways. Identity, sandboxing, human review, and open standards.
Yeah. And maybe one final question for you to mull over as we wrap up. As these AI agents get even more sophisticated, more autonomous, integrating deeper into our lives, what does human review really evolve into? How do we keep balancing their incredible transformative power with the absolute need to maintain control, understand what they're doing, and ensure accountability? It's a fascinating challenge for all of us going forward.
Definitely fascinating stuff to think about, and a great place to leave it for today. That's all for this deep dive into securing AI agents. We really hope you found this information valuable and enjoyed the discussion. If you did, please hit like and subscribe. See you next time.